Hello, everyone, and thank you for joining me for this presentation about Marburg virus. And I'm going to go ahead and get started. Marburg virus is a filovirus that is a cousin to the Ebola virus that everyone probably knows a lot more about. Unlike Ebola, there are no subtypes for Marburg. It's the only one of its kind, and Marburg virus is known to cause a severe hemorrhagic fever in humans, and that's pretty much the hallmark of the filoviruses. Um, Past outbreaks of Marburg have been between 24 and 88% with their mortality rate, so it's a pretty severe illness. The signs and symptoms of Marburg virus start typically with a high fever and severe headache. The incubation period is between 2 and 21 days. These are followed by severe abdominal cramping, nausea, vomiting, and as well as diarrhea that lasts upwards of a week. Between 2 and 7 days, a rash appears that isn't itchy, and also in the 5 to 7 day time frame, severe hemorrhaging begins to occur, and blood starts to leak not only from the gums, the nose, the ears, but most of the orifices from the body. And this is typically what ends up causing most of the mortality of the disease is shock caused by the blood loss. So the Marburg virus taxonomy, it starts with the domain of viruses, kingdom of Riboviria, phylum Negarnaviricoda, class Haploviricoda, order Mongeviricetes, family Monogevirales, phylum Filoviridae, and the species of Marburg virus. And on the right, you can see a picture. It's actually the first electron scanning microscope picture of the virus itself. So for the structure of Marburg virus, on the right, I have a picture of the virus itself. It has a single type of glycoprotein spikes on the outside. It also consists of 4 different types of viral proteins that are VP24, VP30, VP35, and VP40, as well as a large protein molecule and the nucleoproteins. And that makes up the entirety of the virus or the virion itself, and it is also surrounded in a lipid envelope that is typically gained from the host itself. Most of the time, Marburg virus is in a 6 or a U or circular shape, similar to the picture that you saw on the previous slide. The discovery of the Marburg virus actually happened in Germany. This happened after a group of green African monkeys were imported, and the lab that imported them noticed that many of their people in the lab ended up getting infected with Marburg virus and were able to deduce that that was what the infection came from. The natural host for Marburg virus is a specific type of fruit bat, the Pteropodidae family, and as you can see in the picture in the background, that purple outlined area is actually the range that these fruit bats will travel. And even though this Marburg virus has been pretty localized in Africa, they do have a very, very large range that they can cover, so there's a lot of opportunity for infection. As far as the geography and the number of incidents that have happened, the first incident that I spoke about was in Germany in 1967. There were 29 cases and 7 deaths. Also in 1967, there was another incident in what was Yugoslavia at the time. Since then, in 1975, South Africa had an outbreak in 1980. And 1987, Kenya had an outbreak. In 2005, Angola had an outbreak, and it was a very severe outbreak. It ended up with 374 cases and 329 deaths. In 2007, Uganda, 2008, United States and the Netherlands both ended up with a case, and I'm sure many of you had heard of that. That was our Ebola scare that most of us heard or read about at some point in time. Then more recently, in 2012 and 2014, Uganda has seen two outbreaks as well. So the potential for a pandemic coming from the Marburg virus is somewhat low at this time, just due to the fact that we don't have that many, the potential for spread, even though it's high, the amount of mortality and how swiftly it happens doesn't leave much time for the virus to spread. WHO has classified this as a level 4 pathogen, so all of the treatment and PPE and the way that the virus is handled and any of the outbreaks are handled are with the utmost care, due to how easily it's transmitted. Pretty much all bodily fluids, whether it's from a living or a deceased patient, have the ability to transmit the disease. So full PPE is used, and they tend to try to keep tabs on it in the region that it's endemic. As far as treatment and prevention of the Marburg virus, there really is no current treatment for Marburg virus. As soon as somebody is actually diagnosed with it, they do supportive care, rehydration, and oral and intravenous fluids, and treatment to specific symptoms that they're dealing with. But there is no current vaccine or efficable treatment available for Marburg virus. Most of what is done and the WHO's typical response to this is to prevent further spread and secondary cases of the Marburg virus. So as soon as somebody ends up getting infected, they move on to public education, making sure that the communities understand what's at stake and how the disease is spread. They take over and deal with proper burial of the deceased, and they make sure to educate people that safe sex practices are also going to be necessary for anybody that survives the disease, because it is also still communicable through semen for another 12 months after they've survived the Marburg virus. So as far as pathogenesis and portals of entry, as we discussed before, all bodily fluids are capable of secondary transmission. So anything you come in contact with, whether it be sweat, spit, saliva, blood, semen, anything, can transmit the disease. But the primary initial transmission comes typically from a reservoir host, such as a non-human primate, as was discussed in the initial outbreak in Germany in 1967 with the green African monkeys, or it comes from a reservoir host such as the Pteropopidae bat species, the various fruit bat species that live in Africa. It's endemic to them, they carry it, and it's capable of being transmitted to humans through them, through bites or bodily fluid contact as well. As far as the virulence factors of Marburg virus, there's really one protein that's responsible, the VP40 protein. It inhibits one of the immune responses that we have. Give me 1 second here, I messed up my notes. So VP40, it inhibits the Janus kinases and STAT protein responses for type 1 and type 2 interferon expression, and this stops our innate immune response from actually responding to the Marburg virus. So it allows it a bigger leeway for replication without actually having the immune system interfere with it. And that is all that I have for this. Thank you guys for joining me, and if you have any questions, please leave them below.